All right, here we go. Chapter 19, number 22. We did number 20 in class. So we got, does a pull and exercise 1920. Let's just give you the information on this. We have an SRS of, where am I looking here? 100 college students. And we have 53 said they have they view their job prospects as good. Okay, so job prospects viewed as good. And what else do we have? That was it. Okay. Um, okay, so what's the hypothesis for a test to answer this question? We want to know if we have a reason or evidence to conclude that more than half of all seniors think that it's good. Well, H0 is always going to be equal to something, so equal to 50%. And we want to know if more than half, so that's going to be greater than one half. So that would be our hypothesis test to answer that question. So we'd assume that 50% say, yeah, my job prospects are good, and we want to show that more than 50%. And then 23, what's the Z statistic for that test? Well, if I actually did the test, I'm going to go stat. Well, here, I can actually do it right here. So we'll go to stat, test, and that would be a 1 proportion Z test. P0 would be 0.5. X would be 53, because there's 53 out of 100 in my sample. And we want to know it's greater than P0, which is my H0. A value for H0 is 0.5. Calculate. Boom, so Z would be 0.6. Oops, it turns it off when I go to my screen. So there we go on that guy. So there is 23. Let's take a look at 25 now. Do smokers know that smoking is bad for them? I suspect they probably don't, otherwise, well, they do, they just can't quit, actually, otherwise, maybe some don't, I don't know. So the Harris poll asked for sample smokers. Do you believe that smoking will probably be shorten your life or not? Of the 110 people, 848 said yes. Oops. So P hat, without reading any more, I know that P hat, which is my sample, is 848 out of 1010. Harris called to residential telephone numbers at random in an attempt to contact an SRS of smokers. Based on what you know about national sample surveys, what is likely to be the biggest weakness of the survey? Probably since he called numbers at random in an attempt to conduct, my guess is you're only getting residential telephone numbers is going to be under coverage. Because you're only getting the people that have residential telephone numbers. The other thing is you might get non-response. People that are like, I'm just not going to answer the phone or hang up once they realize it's some sort of a survey, and I don't want to talk to people like that. Or it's dinner time or something like that. All right, B. We will nonetheless act as if people interviewed are an SRS of smokers, and we want to give a 95% confidence interval for the percent of smokers who agree that smoking will probably shorten their lives. So we're going to give a 95% confidence interval for the percent of all smokers, given that this is our sample. So that's going to be P hat plus or minus Z star square root of P hat Q hat over N. That's my confidence interval. So it'll be whatever, let's see what 848 divided by 1010 is. That's going to be 83.96%. So that's going to be 0.84 plus or minus 95 is 1.96 square root 0.84 times 0.16 over 1010 That's the confidence interval, and I'm going to go ahead and do that on my calculator. Stat test 1 proportion z interval. Oops. There we go. And x is, what is that, 848. 1010, confidence level 0.95. And there's my final confidence interval. So that's, oops, 81.7, 86.2. 81.7%, 80, did I say 82.6? 86.2%. So I'm 95% confident that the true proportion of smokers who believe it is unhealthy or will shorten their lives is between 81.7% and 86.2%. Okay, never been a smoker, but that seems kind of crazy to me. All right, let's see. Why don't we look at 27? Here we go. Harris announces margin of error. Let's see, same sample. 848 out of 1010 smokers agreed that smoking would shorten their lives. The margin of error was plus or minus 3 percentage points for all samples about this size. Opinion polls announced the margin of error for 95% confidence. What is the actual margin of error for the large sample confidence interval from this sample? The actual margin of error for this is this value right here. That's the rounded number that I used. Now remember in class we talked about, hey, this is the unrounded, because see I rounded it to 8.84. If I find halfway in the middle of this interval, which is 86.2 minus 81.7, actually I'm just going to add them together and then divide by 2. So let's add them together, divided by 2, and so halfway is 83.95. So then the distance to there and the distance down to there, that's my margin of error. So if I go 86.2 minus 83.95, that would be my margin of error. It would be 2.25. So if I go up, it's going to be, well, here, let me make that nicer. My margin of error would be plus or minus, because that's what I add to go up, 2.25, and that's what I subtract to go down. Okay, does that make sense? So that's my margin of error there. Now, the margin of error is largest when p is equal to 0.5. What would the margin of error be if the sample had been 0.5? So let's do this. Let me write this number down here. Let me pause this for a second. Okay, so we haven't really talked about this one in class. So let's check this out. This was my confidence interval. This is actually no hats up here. And we said, here's my confidence interval formula, but because we don't know P or Q, that's the population proportion, that's what we're trying to find the interval for, we'll use P hat and Q hat because that's the closest we could get. Whoa. So we used 0.84 and 0.16 because that's my sample was 84% and Q is the complement of that. And so that's pretty good. Now B says this, The margin of error is the largest when p is 0.5. This number right here, suppose I don't have any idea what p hat is. That is 0.84. I had no idea. What's a worst case scenario for this number? Well, if I did 1.96 times the square root of 0.5 times 0.5 over 10, this number right here, 0.5 times 0.5 is 0.25. Oops. 0.25. And what is 0.84 times 0.16? That's actually 0.13. So this is a worst case scenario. This is the biggest this will be. The P and hat and the Q hat multiplied together. Anything else is going to be a little bit smaller. So if for some reason I don't know what P hat is, I can just use 0.5 and that'll make this the biggest, which will make my margin of error the largest. That's what they're getting at in this problem. So the margin of error then would be 1.96 times the square root of 0.25 over 10. And if I go ahead and do that calculation on my calculator on the side, I'll do 0.25 divided by 10, square root of that, times 1.96, and I get 0.03, which is 3%. So that's your 3% margin of error. That's where, when they said 3%, that's how they got the 3% margin of error, because they used 0.5 and 0.5, whereas we used this. Now this is closer to the truth, to the real margin of error, because P is probably closer to 84, because that's what my sample is, and that's probably closer to the real population percentage. Okay. Why did Harris announce plus or minus 0.3? It's a bigger margin of error, it's a bigger interval, and if you use a bigger interval, aren't you more likely to be inside a larger interval than a smaller interval? Yeah, absolutely. Okay, there we go.